Hello, this is just a brief chat about coding and sharing code. Last week I released this code. It isn't beautiful, clean, or efficient, and my intention is to clean it a little bit today. But this got me thinking, some people might not share their code because they're worried that it's imperfect, they're worried that it's got problems, and they're worried about getting criticism. But I just wanted to make it super clear to everyone that's out there coding that it's fine to share messy, inefficient, and even bad code, because that's how we're able to grow, by getting feedback and criticism. Sometimes the criticism isn't very nice. We all know some people can say things in a nasty way, but what we need to do is sit back and see, is there value to their criticism? Maybe someone said something nasty about the way it's laid out. Now the comment wasn't nice, but it can help us assess how we've laid stuff out and try and improve, and that's what we should always be trying to do. Anyway, I just wanted to show a few of the features of how I'm going to refactor this. Not to go through the whole thing, but just to give you an idea of what I'm intending to do and why I'm intending to do it that way. Because one of the things I'm very interested in doing here is actually just tidying up the main file so that it's got a clear narrative. The first thing is that I've gone through here writing a whole load of notes, going through the whole block of code a little while after I've written it, thinking about how I can change things. We can move all of this to an event manager, and as you come down you can see that we can visualize things just by creating a draw function. Effectively, this is what I'm going to do today. Update everything, move things that don't need to be in this main file into my support functions. And each of these functions should actually be quite small pieces of code like this. These are a bit big here, but that's because they're carrying out an algorithm. But even then it could be split down into stages. So in this little section here, we're checking if there is anything in the injector. The valve has to stay open. Now this could just be tied neatly into a simple function which we can call something like update valve status. We'll put that in the support functions file, and we could actually get it to accept a number so that we could say, actually, we're happy for anything less than 3 particles to now close the valve. We could pass a value into this of 3, say it has to be less than or equal to this value. We're going to copy and paste this, take it over to our support functions. We can just say def status, and we can copy and paste that in, and we can say that that has to be value. Now we can tidy this up even more. We can set valve needs to be equal to this, so that it's updating that flag. So what we need to do is return false or return true, else return true, and we can get rid of this else statement, because if it's returned false it's not going to continue. And there we go. Let's check that that works. Nope, something's gone wrong. We haven't passed it the number in injector. And it's clearly working at the minute. It's maintaining the valve in the open position. And then when we get to just having, it was 3 or less particles within the valve, it will close. So let's see if that happens. And there we go, it's closed the valve. Now we have had a small error occur where actually a particle was caught and managed to escape, but I'm not worried about that a minute. That was a feature in the previous system as well. So what we can do, move straight on to tidying up other areas. And while we're here, we can delete this comment because this line is super clear. So I'm going to continue working at this, and I'll get back to you a little bit later with the tidied file. I've spent about an hour working and tidying this up a little bit and just moving things around. This is where it's really been tidied up a lot. Now you can see there are clear stages where the first part is we have flags that are managed by user input, and then we have the pulse manager. In fact, this could be tied into its own function as well, but I've just left it open, where we can generate particles with a pulse controller. And then this is where this was really complicated, really hard to figure out what was going on, but now we can see that the first stage, when we've got simulation set to true, so the simulation is running, we sort our particles, we decide which walls we're going to use depending on whether the valve is open or closed, and then we have a collision manager which will detect both collisions to the other particles and collisions to walls, and then we also have a particle position manager which will just update the particles after we've taken account of those collisions. And then we have something that removes any particles that are out of bounds and updates our momentum. After that, we have a couple of simple functions that run to check the number of particles in parts of the engines, and then we use that information to update our pulse flag and our valve flag. And then right at the end of all this, we have three simple draw functions to draw the engine, the particles and the UI. This, I admit, is quite ugly at present, but you can see that having just spent about an hour on this, we're already tidying it up so it's much cleaner and easier to read through for someone who's not been involved in this project. The aim of this was just to make the main file much clearer, and so I've obviously overly used that support functions area. Anyway, I hope that's been useful, and thanks for watching. Bye!